Hey guys, how are you? This is video number 2 for the day. This video is going to be on the special right triangles. Hopefully you guys remember them a little bit from the regular school year. The special right triangles are the 45, 45, 90 and the 30, 60, 90. This is the package you should open up and work through with me. I'm going to pull it up in the PowerPoint for a little bit, but the PowerPoint is basically going through these few examples that are here. As you can tell, these are slides. So I'm going to show the PowerPoint for a bit, but again, it corresponds exactly with the packet. We're going to start on page 2 of the packet. Okay, so here we are, guys. We are starting with our special right triangles. And with our special right triangles, it's going to be very important to understand the radical connection. So I just want to go over a few things again, just really quickly here with the radicals. So if you end up with something like 7 root 3 times root 5, then the answer here would be 7 root 15. Again, you can multiply the numbers under the radical, or you can multiply numbers outside of the radical. So if you had 8 root 6 times 5, then this would be 40 root 6, because we can multiply the 8 and the 5, but the 6, again, is not under the radical, so we wouldn't be able to bring that together with it. Another thing we can do, the same type of situation, is we can divide. Again, if we had something like 10 root 6 over 5, then this would be 2 root 6, because we can divide the 10 and the 5. If we had something like 18 root 6 over root 3, we would end up with 18 root 2, because we can divide the radical pieces. All right, so let's get started with our two specials. So for our two specials, we have the 45, 45, 90, and we have the 30, 60, 90. Of the two, the 45, 45, 90 is the easier one because it has the two equal angles. So what the 45, 45, 90 represents are the measurements of the angles in this particular triangle. And as you guys know, if it has two congruent angles, it has two congruent sides. So in the 45, 45, 90, the two legs are going to be x. And again, the legs are the sides that touch the right angle. So these will be our two legs here. These two that I'm highlighting in yellow. So these are my two legs. And the legs are always going to be congruent. So once we've established that our legs are congruent, we need to know the connection between the legs and the hypotenuse. The hypotenuse in any 45, 45, 90 is going to be whatever the leg is times the square root of 2. So this is what this is saying. This is x times the square root of 2. So if this was 4, then this would be 4, because the legs are the same. And the hypotenuse would be 4 times the square root of 2. Again, remember, we cannot multiply the actual 4 and the 2 because they're in different positions. There's either under the radical or outside. We can't actually multiply them and say 8 because they're not in the same position. So our answer here would be 4, 4, 4 root 2. This is the type of problems you're going to see with the 45, 45, 90. How this would get harder, a hard level of difficulty with the 45, 45, 90s would be if you started with the hypotenuse. If you started with the hypotenuse, and let's say this is 18 root 2, then you have to go backwards. If you're going backwards, then you have to think about what the opposite operation would be. To go from here to there, I multiply by root 2. So to go backwards, I need to divide by root 2. Those would go away, and this would just be 18. All right, so let's do a few examples, just see a few quick ones with the slides, and then we will get to the worksheets. All right, so for example 1 here, for this one, it's a 45, 45, 90. So again, we have to think about what that rule was. So the rule tells us that the legs are both the same. So these are both going to be x, whatever that value is. And this is always going to be whatever that is times the square root of 2. So you should automatically know here that this side is going to be 17 because in a 45, 45, 90, the legs are congruent. And then the hypotenuse here is going to be 17 root 2 because we're just multiplying the 17 times root 2. This is just going to be a process of memorization. Obviously, you guys are home, so you don't necessarily have to memorize them, but it's just going to be getting comfortable with that same rule. The legs are the same. The hypotenuse is times root 2. All right, let's move on to the next one. All right, so for this next one, we're starting off with the hypotenuse. So the hypotenuse is 7 root 2. Since we're starting off with the hypotenuse of 7 root 2, we have to go backwards. And to go backwards, we're going to divide by root 2. So again, 7 root 2 divided by root 2. Those will cancel. We're left with 7. Obviously, you don't have to show any formal division there. I'm just trying to show you the process. But most of us can automatically just know that that would be 7. All right, number 3. For our third example here, again, it's a 45, 45, 90. Check. It has to have the angles written in there. If the angles aren't written in, then the sides can be marked congruent as they are here, but it has to be one or the other. You could actually have the angles marked congruent. That would be sufficient as well. But it can't just be a triangle like this and you just start assuming that it's a 45, 45, 90. There has to be something letting you know it's isosceles and right, or 45, 45, 90. So in this case, again, 45, 45, 90, the legs are the same. So if this is 4 root 3, this is 4 root 3. Automatically. That's the rule. That's the process. That's what you have to memorize. Then, to go from the leg to the hypotenuse, you need to multiply by root 2. So this is going to be 4 root 3 times root 2. Again, we did a little practice with this at this point. This should be 4 root 6. So those are our two missing sides. All right. So now we're going to look at the rule for the 30, 60, 90. No, actually, let me just pause. We'll just do a few examples with the 45, and then we'll come back and do the second rule. So I'm going to go to the packets, and let's do page 2. All right, guys, so this is not page 2. It's actually page 3 in our packet that we're going to pick up on, and let's just go through this page. Again, we aren't going to be doing full-on radicals in any like major detail. Okay. So on this page, here we go. Here's the rule. Again, it's listed at the top. The two legs are both going to be x. The hypotenuse is x root 2 at all times. Now, again, we're not going to be doing full-out radicals. So there's a couple of these that I might cross out or adjust as we go through because we're not going to be doing all of the harder stuff with the radicals, rationalizing the denominator and things like that. All right, so for number 1, first example here. Now again, the rule tells us in a 45, 45, 90 that the legs are congruent. So automatically, we should be able to infer that this is 6. And the hypotenuse is always whatever the leg is times root 2. So in this case, this is going to be 6 root 2. 6 times root 2, 6 root 2. All right, I'm going to number 4 next. Number 4, the legs are congruent. So this is 9. That means the other leg is 9. The hypotenuse is 9 root 2. For number 2, now number 2 is one of the ones that, like I said, I'm going to adjust it a little bit. I'm going to make it, let's make this 10 root 6. All right. If I was to divide a whole number by a radical, that's going to require a whole process of rationalizing the denominator that we're just not going to cover in the summer school curriculum here. So that's why I'm just going to adjust it a little bit. So to go backwards from the hypotenuse to the leg, this is again when it'll get a little tricky when you got to go backwards. You multiply by root 3 to go, root 2 to go from here to there. So to go backwards, we're going to divide by root 2. So it's going to be 10 root 6 divided by root 2. Root 6 divided by root 2 is going to be 10 root 3. and the legs are the same. So this one is also 10 root 3. All right, we'll go down into the next one. The next one is number 5. For number 5, the legs are congruent. So if this is 7 root 2, this leg is 7 root 2. The hypotenuse is whatever the leg is times the square root of 2. So that's 7 root 2 times root 2. Now this is going to be one that requires an extra little step, so make sure you follow through here. This will end up being 7 root 4. Again, we can only multiply the 2's because they're both under the radical together. Now, in this case, the reason this one's a little bit more difficult is because we should already know what the square root of 4 is. That shouldn't be a question. Hopefully everyone knows that that's immediately 2. So this is really just going to be 7 times 2. So our answer here is 14. If you come across a problem like that, where it's a perfect square, you do need to simplify that. I don't want it to be left as 7 root 4. If you leave it as 7 root 4, you would lose a point. Okay, so if it can be broken down further, you need to do that, but only if it's a perfect square. All right, for the next one up here, we have 8 root 2. So again, the legs are congruent. So this other leg is the same at 8 root 2. And then my hypotenuse is going to be 8 root 2 times root 2, which is 8 root 4. Similar to the one we just did, we know what the square root of 4 is. So it's 8 times 2. The answer here is 16. Number 6. For number 6, we're going backwards. So we're going to divide. It's 14 root 2 divided by root 2. Ends up being 14. All right. I'm going to move down a little more. All right. I'm going to edit number 9 and make this, let's just make it a 13 root, let's make it 13 root 12. All right. So for number 7, again, if you want, take a second, pause the video, try these on your own. But the 2 legs are going to be the same. So this other leg here will be the same, 6 root 3. The hypotenuse is whatever the leg is times the square root of 2. So it's 6 root 3 times root 2. That becomes 6 root 6. For number 8, we have to go backwards. So we're going from the bigger one to the smaller one. The bigger one to the smaller one means we're going to divide. This is going to be 8 root 3. The legs are the same. And then for the last one here, number 9, we're doing 13 root 12 divided by root 2. That becomes 13 root 6. For both. All right. So I'm going to go back to page 2 there with the slides. So everyone can go back to page 2. We're going to do our 30, 60, 90. Okay. So for our second special, this is our 30, 60, 90. So again, with our 30, 60, 90, these numbers are representing the values of the angles in this specific right triangle. So in this specific right triangle, we have the sides, and they're going to be the long leg. I'm sorry, the short leg is what I'm starting. The short leg. The reason this is called the short leg is because it is opposite the small angle. If we go back to the triangle inequality chapter, we learned that opposite the smallest angle is the shorter side, or the shortest side. So in this case, the x, well, first of all, we know they're legs because they are the 2 sides that touch the right angle. So these are the legs, 2 that I'm marking here in green. And out of the 2 legs, again, one of them is shorter than the other. So hence we have the short leg and the long leg. So this is our short leg here, and our short leg is going to be our starting point pretty much for this. It'll be our x. All right. Now, the long leg is going to be our other leg, and we'll just say the long leg. And the reason it will be called the long leg is because it's opposite the bigger angle. So between the two legs, it's the one that'll be longer. And then we have our hypotenuse, obviously. And this over here is our hypotenuse. Now, for our hypotenuse and our legs, this is going to be our rule. Our short leg is the starting point. It is x. Our long leg is going to be whatever the short leg is times the square root of 3. So whatever this is, we're going to multiply it by the square root of 3. Then our hypotenuse is whatever the short leg is times 2, regular 2. No root 2, this is just regular 2. Now, at this time, students are normally kind of asking, like, what is this stuff? Where does this come from? What's important to understand is that for every single right triangle, there exists a relationship between the angles and the sides. It's like a proportional relationship. It's not that, they all have to be congruent, but based on this, what the angles are, there's a proportionality with the sides based on like the angle measurements and things like that. So basically our 30, 60, 90 is representing that like proportional like type of relationship that's shared between the sides. Now, there exists a relationship like this between every single triangle. There could be quote unquote, a 18, 72, 90 triangle. But there's no way we want you guys to memorize like every single relationship that exists. So the only two that you are required to understand the shortcut for, understand the relationship, are these two, the 30, 60, 90 and the 45, 45, 90. So obviously the 30, 60, 90 is a little bit more challenging than the 45. And the only reason it's a little bit more challenging is because of the 45, 45, 90, two of the sides are congruent. So in this case, we don't have any congruent angles, so we don't have any congruent sides. So in that regard, it's a little bit harder. All right, so let's move on to our first example. All right. So for this example, again, I'm going to write the rule here for us. The short leg is our start. It's always like kind of what you would hope everything was based on the short leg. Obviously, that's not going to be the case. It would be too easy if we always started you with the short leg. But the short leg is our starting point, it's x. The long leg is opposite the 60, and it's going to be that times root 3. And the hypotenuse is 2 times the short leg. Again, everything is going to revolve around the short leg. So the short leg is 4. So that means that the hypotenuse is 2 times 4. 2 times 4 is 8. So our hypotenuse is 8. Our long leg is going to be 4 times the square root of 3. 4 times the square root of 3 is just 4 root 3. For the next one, number 5. For number 5. Now this time, we're not starting with the short leg. We're starting with the hypotenuse. So when we're starting with the hypotenuse, you have to think about how we go backwards. Again, going backwards is the thing that'll be a little bit more challenging. If we start with the hypotenuse, think about it. If we multiply by 2 to go this way, to go backwards, we do the opposite, which is to divide by 2. So we'll do 18 divided by 2, we get y is 9. Then, from here to there, you multiply by root 3. So this is 9 root 3. For 6 here. For this one, we're going to start off with the short leg again. because this over here is opposite the 30. So this is my short leg. My short leg is x, my long is x root 3, and my hypotenuse is 2x. So this time, even though I'm starting with the short leg, it's a little bit more challenging because this already has a radical involved. But it doesn't matter. We should now be semi-comfortable with multiplying with some radicals, some basic operation with radicals. So in this case, this will be 6 root 15 for y. And x will be 2 times this. So it'll be 2 times 6 root 5, which is 12 root 5. Okay, so that's the end of page 2 here, guys. So everyone just take a second and take the packets, and you're going to go to page 4 in that packet. I'm going to flip back to the packet. All right, guys, so I'm picking up on this is page 4 now in the packet, and this is our first 30, 60, 90 page. And so here on our 30, 60, 90 page at the top, again, once again, the rule is just stated, and you need to be comfortable with the rule. Again, obviously you are home, so you don't have to memorize it, but you need to be comfortable with the rule. What does it mean? It means that if you know the short leg, everything else revolves around that. All right. Excuse me. Again, I might change a few values on the fly here, as they might just be a little bit more than I want to do as far as with the radicals. Okay, so let's get started for number 1. For number 1, this is what you want. If you can get a problem when you're starting with the short leg, this is the short leg, then that means you're starting with pretty much the whole nucleus of everything. You start with the short leg, it should be pretty easy to figure out the long leg. The long leg is the short leg times root 3. Excuse me. So 8 times root 3 is 8 root 3. The hypotenuse is the short leg times 2. So this is going to be 2 times 8, which is 16. Again, that's ideal if you get the short leg to start, because you don't have to do like any working backwards. Everything is come straight from the short leg. The next thing you know for I'm going to go to 4 next, and I'll go back up. For number 4, 4 is also starting with the short leg. Again, if this is 60, that means this one's 30. That's the short. The short is x, the long is x root 3, the hypotenuse is 2x. So if this is 7 root 3, the hypotenuse is going to be 7 root 3 times 2. Again, at this point, we spent some time reviewing these radicals. 14 root 3 is our answer. You can only multiply the numbers that are outside the radical by each other. All right, now for 4, for the long leg, it's going to be multiplying by root 3. So that's 7 root 3 times root 3. 7 root 3 times root 3 will end up being 7 root 9. There was a problem on the previous page where I told you guys if you end up with a perfect square here, you should be simplifying it. So hopefully you guys recognize that 9 is a perfect square. Square root of 9 is 3. So this is really 7 times 3. So this answer is 21. If you leave it as 7 root 9, you will get some credit, but you will definitely lose at least a point. Next problem. Number 2. For number 2, this time we are not starting from that nucleus, the small leg or the short leg. We're starting from the hypotenuse. So again, I'll write the rule. This is x, this is 2x, and this is x root 3. So if this is 12, to go backwards, I need to divide by 2. Yeah. If I multiply by 2 to go that way, I divide to come back. And then over here, I multiply by the root 3. For the next one, number 5, this one's not as user-friendly, but it's definitely doable. For this one, you're told that the hypotenuse is 9. So again, we go backwards. So if we do 9 divided by 2, it's going to end up being 4.5. And therefore, the long leg, it's 4.5 root 3. All right, for the next one, for 3. This is the long leg. That's 10 root 3. That means that the short leg here, we would divide by root 3. So it's 10 root 3 divided by root 3. Cancels. 10. That's 10 times 2. This is 20. All right, so for number 6, this one we're going to edit a little bit. For number 6, let's say this is 12 roots. Let's go with 15. So I need to go from my long leg to my short leg. So the rule I know is that this is x and this is x root 3. So if I want to go backwards, I need to divide by the root 3. Since it being 12 root 5. And my hypotenuse is that times 2, so 24 root 5. Number 7, for number 7, we have a long leg of 8 root 2. And this one wouldn't work out. Let me just make it a little bit better. This one would be a nice one. I want to make it 8 root 21. Again, I'm changing it so it's something that's better to deal with. Because if I had 8 root 2 over root 3, again, it's doable, but this is if we spent more time with the radicals and spent more time working with that piece of it. We're not going to do that. We're just kind of skimming the radicals a bit, just touching on it. So I don't want to give you anything that's a bit too much with the radicals. So by me making this 8 root 21, hopefully everyone understands why that would be a little easier to deal with. Oops. 8. All right, so we have 8 root 21. And I want to go from this backwards. Remember, this is x root 3, and this is 2x. So to go backwards, I'm dividing by root 3. So now these can divide, so it'll be 8 root 7. This is 8 root 7. To figure out the hypotenuse, I multiply by 2. It's going to be 16 root 7. And then for the next couple, for number 8, I'm going backwards from the hypotenuse. Feel free to again pause the video, try these last two on your own. You should try a little practice. Let's go backwards. I'm dividing by 2. This is going to be 6 root 6, which makes my long leg 6 root 18. Now, some of you, if you are utilizing a calculator at some point, you might see that some of these answers for the radical piece are a little different. And that's because if you have a calculator that simplifies radicals, it's going to simplify it correctly. I'm going to allow you guys to leave it as a 6 root 18 because, again, our goal today isn't to, spend forever simplifying the radicals. All right, for number 9. This is the short leg because that's opposite the 30. So this is x root 3, and this is 2x. This is going to be 10, and this is going to be 5 root 3. All right, so go through here, a little bit more practice, just more and more of these. I will post some of the answer keys from some of the ones we did in class so you guys can look them over. I recommend you try a few of these pages. There is an exit card that will be due. Between the 2 exit cards, one of them will go in as your homework and one of them will go in as classwork. Since I was a little late posting this, since this was like some of this was a homework from yesterday. So the homework from tonight I will attach, and you guys will be able to do that. All right, have a great day, guys. Hope this helps. If you need help, I will be posting an extra help link at the top. So feel free to click on that and come in for extra help. I know tomorrow will be Tuesday at about 4:30. I'll try to make myself available on Friday as well. Have a good day.